So after digitizing, we have to validate our topology. Now we have two layers here, an uplands and a lakes layer. And because of the digitizing trick, there shouldn't be any errors, but we'll go through how to find errors and we'll show how to fix them. So remember, we created this topology with a 2-meter cluster tolerance and various participating feature classes and rules about how those feature classes were supposed to interact. And we've digitized two layers, the uplands and lakes. Now to use the topology, we have to make sure the topology toolbar is on, which we've checked here to display. And we also have to start editing. The toolbar will be grayed out until you turn editing on. And so we'll add the topology to our data frame, and we'll add all the participating layers, even if we have some already in the data frame, because it links the topology to the layers. So we should delete those that we had displayed before. We don't want two copies of the same thing displayed. So we'll delete those unlinked ones. There's a way to link them, but it's just as easy to add them together and delete any that were there before and are unlinked. So we have the uplands and the sublakes are two layers that we've digitized. And we're going to validate the topology. Now we'll start editing, and we'll talk about two primary tools that you use the most in this loop. So one is the validate within the current extent. It looks for those errors. And then the second is the error inspector or error table. It'll display the errors it finds. You can click on the table icon and then search for the errors. Now, as described in the lab, there's only this pseudo error along the northwest edge because the rules aren't perfect in defining what we want to define, but the error shows up again with this sort of pinkish display. We'll add a few errors that might occur, common kinds of errors when you're digitizing, so you'll know what they look like. So first I'm going to add an overlap here where the uplands overlaps the lake, and then I'm going to add a gap. So I'll pull here to add a gap, and you can see the image poking through. There's a gap there behind, and I'll save these edits. So now when I validate the topology, it finds those errors. And when I look at them in the error table of the inspector, they show up highlighted with those error colors. And if I left click on each one, the current error is highlighted in black, or I can right click on a selected error and zoom to that error and see it, in this case, this overlap. Now I'll turn the topology display off and edit using the edit tools and the caret. So if I remember, double click on a layer with the caret, I'll display the vertices, and then I can pull the boundary back to its correct position. Now I want to go save those edits before I validate the topology. And then when I do that, I'll look and it'll show, yeah, there's only the one error left. The other error, there were two errors associated with that, disappeared. That overlap generated two errors. So if I left click and zoom to the remaining error, we can see, oh, there's just this one left. So I'll go ahead and fix this second error now. Again, showing it here in the displaying it in the topology. Grab that vertex and pull it over. And then I need to be sure I save and validate before I check for errors again. If I don't validate, the errors still exist. So I've saved, and I look now, that error is still there. The topology thinks it's there because I haven't revalidated it. When I revalidate it, it rebuilds the topology, and I see, yeah, there's no errors. I can search for them and they all disappear. Now, one other thing about this topology is you don't have to search and fix all the errors at the start. When you validate the topology, if you have an error that's smaller than your cluster tolerance, it automatically fixes those. So these little slivers that might occur while digitizing will disappear if they're below that 2-meter cluster tolerance that we specified for our topology. Now, we don't want to make this too big because that limits the precision of our data. But if we do have small errors and we go ahead and validate the topology, right? So we've saved that error we introduced when we validate the topology. The error will automatically be cleaned up. The topology moves the vertices by that up to 2 meters to close those gaps.